Hello everyone, welcome to School Quiz. So this side Anjali C, and this is a session. Sorry, in the previous session we discussed about the equations of motion. Okay, so in this session we'll discuss about the uniform motion, uniform circular motion, and the graph which will tell you about the uniformly accelerated motion. Okay, and some other graphs also. So I'll start the session with sharing my screen. Okay, so are you able to see? Yeah, here first, I'll, as I told you, we'll study the graph. So speed time graph, when the speed changes at a uniformly acceleration. So you can see this is the graph, this is the speed time graph, and you'll get the body is moving uniformly. Okay, means the body is changing its acceleration with respect to the time, and it is changing in a uniform manner. So that is the uniform acceleration. Clear? So acceleration is the change in speed with respect to the time taken. So this slope, actually this line, this OP line is the slope of this graph. So this slope of the speed time graph of a moving body gives its acceleration. Clear everyone? So we'll move towards the next graph. There are a little information related to the graph so that you are master when you're drawing a graph. Okay, you'll not face any problem when you'll see the equation, or you can say the problem which is related to the graph, and you are able to do the to make the graph. Okay, so here the next graph is, again, this is a speed time graph. So here in this graph, it is again a uniform acceleration, but here the acceleration is decreasing. Here the acceleration is decreasing, and I told you the decreasing acceleration is known as retardation. So this is the graph of uniform retardation, or you can say deacceleration also, or negative acceleration also. Clear? And the next graph is, yes, about the, this is also speed time graph, and this is the uniform acceleration. But you can see, again I'll see the first graph. In the first graph, the object is at rest. Initially the object at rest, and after that it start attaining the speed. But in the next graph, you can see the object is not at rest. Okay, object is not, initially the object is not at rest, it has, or it acquires some speed, then the speed got decreases. And in the third graph, again the object is not at rest. Okay, it already acquires some acceleration. Okay, see, when initial speed is not zero, here the speed is not zero, and I think you can recognize the shape of this graph is OACAO. Okay, the graph name is OBCAO. This is the trapezium. Okay, the shape of this graph, if in the question is asked the area of this graph, so what will be the area? You will find the trapezium. Okay, you'll find the area of trapezium means sum of the bases multiplied its heights. See, sum of the bases multiplied its height and by half. Clear? So this is the uniform acceleration. Now, the next graph is about the non-uniform acceleration. In every graph, you see the speed changes in an equal manner, or you can say in equal interval of time. But in this case, it is non-uniform. Okay, here the speed changing non-uniform, and it acquires the non-uniform acceleration. Clear? So this is about the graph where you can observe the uniform as well as non-uniform. And in case of uniform also, you can see the sometimes it is uniformly increasing and sometimes it is uniformly decreasing. Clear everyone? Now, Oh, sorry. This is the uniform circular motion. By mistake, it cuts, but the topic name is, okay, I'll write it because it's not good. This is what, dear? I don't find the space, but this is the uniform circular motion. What it is? Uniform circular motion. Okay, you can see there are uniform circular motion. Automatically, the object is moving in a uniform circular motion. Like this, you can see this is the merry-go-round. Okay, this is the this is the merry-go-round. Okay, what happened? This is the merry-go-round. And this is what? This is the CD player. When you'll keep, now it is nowadays you hardly you observe this, but yes, in our times, it is very famous, and it is moving in a uniformly. Okay, it is moving uniformly. Clear? Sorry, it is moving uniformly. Now here also, this is the square track, hexagonal track, octagonal track, circular track. Okay, when you'll see, they are moving uniformly. This is not in the form of circle. This is also, and this is also, but this is the in the form of circle. And when you'll move this in a uniform manner, so it shows the uniform circular motion. Okay, and the definition is, when an object moves in a circle is called uniform circular motion. Any object which moves in a circle, that is the uniform circular motion. I think that is clear to you. Now we'll move towards the more example. Example, okay. Yeah, example, the first is artificial satellite move in uniform circular motion around the earth. Okay, so we don't have to, we are not able to observe this, but yet the artificial satellite, which is in the, which is above the sky, they are actually moving in the form of circular motion. Okay, they are in the form of uniform circular motion. The motion of a satellite around the earth is accelerated. Okay, they are moving in the form of circular motion, as well as they are they are uniform also. Okay, so means they are changing its speed, they are changing its speed equally in equal interval of time. Okay, so when an artificial satellite go around the earth in a circular orbit with the constant speed, the velocity is not constant because the direction of the motion of the satellite is changing continuously. Here the direction is changing continuously, but its speed remains constant. This is the, okay, I'll write it here. Here what the motion, okay, you can see here the yeah, constant, but the constant speed, the speed is constant. Okay, and the most important, the velocity is not constant. Here the direction is changing, but it is changing uniformly. Speed is also changing, but the velocity is not. Here the velocity is not changing. Okay, velocity is not changing. The condition is, first condition is this. Second is speed is constant. Speed is constant. And the direction, what about the direction? Direction is changing continuously. Okay, it is changing continuously. Sorry for my handwriting, but the direction is changing continuously. Clear? It is the force of gravity of the earth which keeps a satellite in circular orbit around it. And this is the, you can say this is a universal concept, that there is a universal law of gravitation. With the help of gravity only, this satellite is able to move around the earth. Okay, because of the gravity only. Now, we'll see the next example. First, I have to erase all this. Erasing this, the erasing of all this. After erasing only, now, yeah, while erasing, I'll tell you the next example. The moon is a natural satellite of the earth. It is also moving around the earth. This is a natural satellite and it is also moving around the earth in a uniform circular motion. They are the universal example because they has to move. Clear? Okay. And the earth moves. Yes, the next is the earth move around the sun. This is also moving in the form of uniform circular motion. Okay. Clear? Now, next is about the an athlete. You can see these are the examples. An athlete moving on a circular track with a constant speed exhibit uniform circular motion. When it is moving in a track, so that time also their speed is constant. Clear? And the last, the tip of the seconds hand watch. You can see the seconds watch, the second as well as the minute as well as the hour. They are moving uniformly in the watch. Okay, so these are the a common example of uniform circular motion. I think that is clear to you, everyone. So I'll stop my sharing screen. So today we read about the uniform circular motion and some graph of uniform acceleration as well as the non-uniform acceleration. So please revise it, stay healthy and keep safe. Okay.